pretend.
There you are.
Hey, let's start. So, hi everybody. I'm Wojciech. I run a small development studio called Brains and Beards. And basically, I'm not gonna talk about myself. I'm gonna talk about Daniel Everett. This is the guy on the left. He's a missionary that went to the Amazonia in 1978. He was one of he belonged to one of those Christian groups that think that it's very important for them to pass Christianity to other people, and they're like, there's not much people left who don't know what Christianity is. But there was this tribe of Indians living in the Amazon, and he wanted to go there. And the rule is that you have to translate the Bible into their language so they can learn with it themselves. The problem is that nobody spoke their language, literally nobody but them. So he went there to learn their language. And a lot of things happened. He became an atheist, and he was not a missionary, obviously, anymore. And then he became a language anthropologist. But the important thing is those Indians. And they are called the Piraya people, and they are their language is from a bigger group called Mura. And it's about between 180 and 350 people who approximately speak this language still. And amongst one of them is the Daniel Everett, who is basically the only source of our knowledge about them. And what's interesting about them? What's interesting about their language is they don't have colors. For example, they cannot say the sky is blue, my shirt is red. They would say, if you have a blue shirt, they would say your shirt is the color of sky, your shirt is the color of blood, stuff like this. They only have words that mean light and dark, something light outside or dark inside. What's more, they don't have a concept of something like far future or far past. So they cannot, for example, they cannot say, oh, remember this time 2 years ago when we managed to hunt a snow leopard, leopard, and ate it? They cannot say, remember 2 years ago, because there's no such thing as 2 years ago. This implies there's no history, so they have no myths, how they came to be, so there's no religion. There's nothing that happens after death, because you cannot say what's going to happen in 2 weeks. So there's no ghosts of your ancestors that are roaming around, because you don't really have ancestors. They don't say the ghost of my grandfather, because they don't know what grandfather is. They don't have a word for it. They have a word for a parent. This is the same for the mother and father. And they have, I think, 2 different words for brother and sister. And that's it. That's the whole family that they have. So, but what's most important for us is that they don't have numbers. And this gets tricky. Because they've been trading with the Brazilians for years. And when it's difficult to trade when you don't know the numbers. And so what they do have is 2 words. One is hoi and the second hoi. There's the same word, just different accent. And one means 1 and the second means 2. They also have a complicated construct that says many twos, which means a lot. And so Daniel was there for more than 20 years. He was there for 20 years before he got a fridge, and now he's still there, but with a fridge. So he improved his life. But basically, he made experiments when he was trying to figure out what the words mean, because there's no language teachers there. So he puts a stone and how many stones are, and they say hoi. He puts 2 stones, how many are hoi, and okay, so 1, 2. But then he followed a bit, and he changed the experiment. He puts 10 stones, and then asks them how much it is, and they tell him many twos. And then he starts taking away the stones, and every time he takes away the stones, there were 10 stones, and they have 3 words for it. So it's seeing how it changes, and it turns out that some of them got to 1, the word that he thought meant 1, when there were like 4 stones, some when there were like 6, some when there were 5. So basically the words, they don't really mean a number, they need like a small amount, a large amount, a very large amount. So when you're starting with 0, a small amount is 1, a large amount is 2, because like multiplication by 0 is like you get crazy infinite stuff. But if you start with 10, then 8 is not a small amount. Also, it's not a very large amount, and things get complicated. So what the Indians realized was, okay, this shit is complicated, and it would be cool to learn it. And now we have a white man who speaks our language. We're gonna use him to learn all the stuff, so that next time we're trading 3 knives for 5 fourths of a beaver, we will actually get 3 knives, not 1. So he started teaching them, and he spent, I think, 3 months teaching them a group of them, every single day. The classes were in Portuguese, and after 3 months of daily lessons, none of them could count from 1 to 10, like 1, 2, 3, 4, 5, 6, 7, 8. And none of them could tell him how much is 1 plus 1. So this is kind of basic mathematics stuff, right? So what we're dealing with here is linguistic relativity. This is the idea, is like the called also Sapir-Whorf hypothesis, that the language you speak limits your understandings. Like also Wittgenstein says it, that if you cannot give a name to something, you don't think of it. There's some ideas are unimaginable.
I had a teacher that used to say that you think in words, or you think with words. So the more words you know, the better or more accurate you can think.
True. And for me, like, I speak English, I'm Polish, and well, I speak Spanish a bit. And the way I think, when I speak English, I speak in a different way and construct sentences in a different way because my brain works a different way. And for them, it was like they don't know what the numbers are. Even if you teach them the words from their cultural context, it was very difficult for them to understand what's going on. So, but let's get to the point. Like, we're not those Amazonians, we're like fancy programmers, we can program really fast. This is actually authentic news footage from my hometown. So this got on the news. We are also a community that we deal with languages and they limit us. For example, I come from a Ruby background, and these are things like numbers to the Piraya people, like compilation errors. Like, what are the compilation errors? What's a compiler? There's not stuff that I deal with, like type systems, immutability. There are like concepts that somebody can try to explain to me, but I cannot relate them in any way to my daily work, to things that I know. So it's very difficult for me to learn them. And obviously, those are things that I think we can all agree that are useful, and maybe you don't have to use them all the time, but it's worth to know them. Like, and being a Ruby programmer, I kind of limit myself to ideas like this. So that's the whole point of this talk. That learning new languages expands your mind. That gives you a way to think about some new concepts, and it's actually helps you even if you're not gonna use the new language, you can still use some ideas in your own language. And the problem I have with learning new languages for a long time was like I didn't have any decision-making power. I was like a developer in a company, and okay, I want to learn Clojure, but the way I do it, I would have to sit on a weekend and do it, but like the sun is shining and the beach is here, the mountains are there, like it's not really a big priority. And for me, I couldn't, like, so like if you do it on the evenings, you do it on the weekends, you cannot dedicate so much time into it. You should do it on a real project. And for me, the only solution that seems to work was like try to use it at work. Like then you're stuck 8 hours, 5 days a week, working on stuff that you want to learn. So for sure you're gonna progress. And I'm trying to address and the problem was how to do it. And I think it's a lot of us could benefit from doing so. That's why I'm gonna talk about how to try to force it in your, try to convince them it was their idea that I'm writing in a language I want to use. So, of course, what might happen is you get fired because you fuck up, because the language you propose, like, it's not gonna work, right? But fortunately, the job market is like it is, so maybe you will be able to find a new job in the language that you like. No, but seriously, in this job market, you people don't get fired. So, the most important thing that we need to remember is that any kind of change is not easy. People don't want to change. Like, just because I want to learn a new language doesn't mean all my coworkers want to learn a new language. And you have to be really careful about what you're proposing. You cannot just, like, on every meeting when somebody says, let's do this feature, you just like jump out and say, yes, let's do it in Clojure. Like, after 3 meetings, they will just ignore you, or maybe it's a good thing, like, they will stop inviting you to those meetings. But what's not gonna happen is you will never ever learn Clojure in this company. So what you should do is try to find a good moment, like wait for the wonderful meeting when somebody proposes something that actually would make sense to write in Clojure, or Haskell, or Elixir for the matter, whatever language. And you just have to wait for the right moment, because if you propose in the wrong moment, they might even go for it, they will try it, it will fail, and then they will never try again, because they say, yeah, okay, like you said it before, we tried it and it doesn't work, so let's move on to normal stuff. And another cool thing that you can do is benchmarks. Of course, we all know that benchmarks are bullshit, and like it's very, very difficult, like the guys from NoFlop Squad talked before, it's very difficult, takes a lot of effort to make a real-world benchmark, to cover all the cases, what happens if there's big load on the server, what happens if there's small load, and so on. But there's this theory that this requires a lot more effort to override some bullshit than it takes to produce it. So what will happen if I'm gonna like, we have a small piece of code, and I'm gonna rewrite it at home in Haskell, and it's gonna be 20 times faster, and I'm gonna show them the benchmark. So if they want to discuss it with my manager, who doesn't really write benchmarks himself, they will have to produce their benchmarks showing that it's not really 20 times faster. So it's not like me saying, oh, but it will be faster. No, I'm showing the numbers, and I'm showing that I'm serious about it, that I put some effort in it. I already re-implemented part of the functionality in a different language, and the persons who make the decision, usually it's not the developers themselves, it's the managers who need to agree. It's usually like when they see numbers, they're okay, like, this guy is serious, maybe it makes sense. They think, okay, we've got 10 servers, this thing's 10 times faster, and one server costs us like $1,000, so maybe it's like $9,000 here. It's not really true, the benchmark that you show, but it can let you start working. So another thing is you want to make small changes, because one thing is doing any radical big changes to production systems based on your instinct is probably not a good idea. And the other thing is that you will show results fast. Like if you say, okay, I want to rewrite this part, how long is it going to take you? I don't know, like 6 months, 7 months, 8 months? They're not going to go for it. But if you tell them, okay, 2 weeks, and then we'll see the results. If it's faster or not, if it's not faster, we can just throw it away, because what we're throwing away is my 2 weeks of effort, which is not that much. And if you spend 6 months on it, then nobody will throw it away. And even if your solution was not good, it will stay there, because nobody wants to write it back. And your team is going to hate you, because you're responsible for putting this monstrosity in the project. So you should operate on some small iterations, like, okay, this part we can change in 1 week, let's change it, see what happens, and we can roll back. So it's also important that you shouldn't really be like connected emotionally to the code you wrote. That because if somebody says, okay, it's not good straight away, well, you try to make as good a job as you can, but sometimes it's not good enough, and they will throw it away. Another thing, any internal tooling. This is a great place to start because if you have a commercial product that people use over the internet and it stops working, then they will just stop using it. If you have an internal product that stops working and people who are using it are working in a room next door, they will gonna come and punch you. So you will get this immediate feedback that something stopped working. No, but seriously, the issues will be reported because they know how to report the issues. They really care about it. It's not like they can stop using internal tools. And also, afterwards, when you fix it, you can take them out for beers and explain, yeah, I'm trying to do this thing, I'm sorry I break it, but well, in the future it's gonna be better. So they can forgive you. Like, production users, like external users, are not so forgiving. They will just go away silently. The numbers will go down, and the manager will not be happy. Also, important thing about the internal tools is you control the APIs. That if you have some kind of API that you expose outside, you cannot change it. Like, for example, let's say you switch languages and the way they format the dates by default is different, and you break all the clients because, I don't know, Ruby serializes dates to ISO 8601 and like Clojure serializes something else, and their stuff breaks, then you're responsible for it. But all this stuff, all the APIs that are internal, you can just, okay, if it's your internal tools, you can go to their repos and fix it on their side and it's gonna work. So this is something negotiable. Like, you can find people who are responsible for it and help them change it. And my favorite method is the under the radar method. So basically, you make a rewrite that nobody knows about, and you don't tell anybody unless it works. So it works great for database migrations, for example. You're migrating data from Redis to InfluxDB, and you know you're going to run it once because your old servers are going to be deleted, and then the code gets thrown out. Then you can write this migration in whatever you want because you're the only person who's going to run it. It's going to be run once. It's going to be deleted afterwards anyway. And if it doesn't work, you can still go back and write it in the language that you were supposed to write it in. But if it works, you can tell them, remember that the downtime was so low, it's because I used Haskell for it. So you can, if nobody knows that you're doing this, you can get the credit for all the successes and just like not mention your mistakes. What's important here is to be able to take the credit for the good work that you did, was to A/B test the solution you did. For example, you run the same migration with how it would take like with Ruby or how it would take with Clojure, and like you compare it and say, okay, like this solution, maybe we should do it in the future like this because it's better, it's like more safer, the error handling is nicer. So it could be database migrations, it could be any kind of analytic scripts that you use internally for business intelligence, anything that is anything that you write once and then you forget about it. Most really important stuff, you should not change anything that is mission critical, because you might think that if something is really important and you change it and it's gonna run better, then they will be really happy. It's not gonna work like this. It works the other way. If something is really important and you're gonna fuck up, they will be really unhappy and they will fire you. So this high risk, high reward environment is not a good place to be. You should aim for something that nobody really cares about, because there is a bigger chance that they will let you do this. Okay, we're gonna go through a few types of projects and how handle those situations, because depending on the architecture of the project, it might be easier or more difficult to do those changes. So something that's really simple is any kind of publish subscribe queue. So you have like RabbitMQ, AMQP based application where you just publish events and they will have some clients subscribing to them. Then you can switch any of the publishers or any of the clients to one written in your language of choice, and nobody's gonna notice as long as they still use the same queue. So you can do it without telling anybody, or usually there are pretty small that you can rewrite them relatively fast. And usually those publisher subscriber queues are like, they have bindings for every language that you might want to use. It's like just RabbitMQ, and there were more, but I didn't fit on the slide, so I'll get the point. So the Docker architecture. You have like a service-oriented app. Then again, you're in a cool situation when you have a bunch of services that communicate with a clear API with clear borders between them. So as long as you rewrite it that it also uses the same JSON like everybody else, or the same protocol buffers that every other service, and keeps the same API, no, you don't have to touch any other parts of the system. You can switch one small part, preferably the smallest one you can find. The best one to choose would be like some like invoice aggregation that nobody ever wants to touch, because then because after changing the code, for a long time you will be the programmer who's supposed to maintain it until the other people on the team get to know the language. So if you choose something that nobody likes and you will be the sole maintainer, they will support you in your quest. So, for example, I come from the Ruby background, and it's going to show a little bit in the. So, for example, if you have like a service-oriented architecture built in Ruby on Rails, and you want to have a conversation about switching some of the services, you can, for example, propose the Elixir and Phoenix. So Elixir is this Ruby-flavored Erlang, basically, that compiles and runs on the Erlang virtual machine. And Phoenix is a web framework that is also heavily inspired by Rails. So what your angle in this situation would be, okay, I understand we're introducing new language, but it's not a new language and new framework, because you see Phoenix is based on Rails. So you've got the models, you've got the controllers, like a lot of things are really the same. You have this middleware layer, and it's like plug, rag, the names are different. The names are similar, so it's easier for them to move from Rails to Phoenix than if you proposed, for example, I don't know, Java beans or whatever. And they say, okay, like, so if it's the same, why would we use this? And you say, okay, but here you get Elixir, which is a compiled language, which is going to be faster, you have better concurrency. And they were like, yeah, but like we Ruby programmers, we don't really give a shit about the performance. So they say, okay, but a lot of networking stuff is gonna get easier, and your code gonna get nicer, the concurrent stuff. Say, okay, maybe we'll see. Or you can try a different angle and say use Haskell and ESOT. And again, like ESOT is like a web framework built on Haskell. It has some similarities with Rails. It doesn't go really far, but you can use it as a selling point. There is some stuff that overlaps. There is some kind of familiarity in the beginning, but so what you do is you pretend that ESOT and Rails are practically the same, which is not really true, but there's an angle you can play. And what you're saying is Haskell, they're okay, performance, they don't care. You say types, that like remember how all your tests run so long because you have like shitloads of them, and because Ruby is a dynamic language and you want to make sure that correct stuff is being passed around. But with Haskell, you get rid of 90% of them because of the types, and compile time checks make sure that stuff is being passed around correctly. And you're like, okay, I'm listening, and then you tell them that with yes or like stuff that you tell them stuff that's not achievable in your language. In the example of yesterday, it would be it's capable using the compiler. It can check the types of all the URLs that you have in the application to make sure that you're not using an old URL that points nowhere, basically. Because with Ruby, you've got like those helpers that create URLs, and there's no guarantee that this URL is available. With Haskell, you have the compile time guarantee. You've got like compile time checks for cross-site scripting, cross-site request forgery, and a lot of security stuff that normally you learn about when you get hacked for the first time. So the point here is that you're trying to show the similarity, but sell the stuff that's gonna actually improve your daily workflow. We're gonna skip through this one because that's what I just talked about. There's like a pet peeve of mine that there is no such thing as like front-end developers and back-end developers. Even for when you look at job descriptions or like job postings, then everybody says, we're looking for a front-end developer with React.js. We're looking for a back-end developer with Java. And this is bullshit. We're all developers, and we should try to embrace the other parts of the system that we might not really like that much. But for a long time, I classified myself as a backend developer just because I cannot write CSS. And it's kind of limiting because there's a lot of parts on the front end that I can do without writing CSS. There's a lot of JavaScript that gets really interesting. There's a lot of people who do mainly front-end works, but they're afraid to touch any single line of a controller in Rails because they are not backend developers. And when somebody looks at the code review on the div and like, why are you touching backend? Because like you're a front end, like for sure you fucked it up, did you change the test? And there are perfectly competent developers who just like this part of the code. So if you're like trying to learn new languages, we shouldn't limit yourself. Okay, I'm trying to learn new languages, but just on the backend side. It's a bit like, okay, I know Ruby, I'm gonna learn a new language, I'm gonna learn Python. This makes no sense whatsoever. Like the languages are so similar that when you're gonna learn something that's outside of your comfort zone, learn something that actually will make you a better programmer, something that will introduce new concepts. And one of those things would be like you're doing backend all the time and you start working on the front end as well. I'm not advocating touching CSS because it's a pile of shit, but maybe this would be a good choice. This is actually a JavaScript program written by me. Like I'm there in the background coding it, and that's how it looks. So, as I said, you could try working on the front end stuff and switching to JavaScript, but it's a pain because it's like really unpleasant. I could watch it for hours. It's really unpleasant experience, but fortunately there are a lot of options that allow you not to make it better. There's this talk about Elm called "Make Your Backend Team Jealous," which I think sums it up really well because nowadays, according to the CoffeeScript wiki, when I created this presentation, there were like more than 300 options listed in their README about languages that compile to JavaScript. And I think this is enough to find something that you will like. And it is so much easier to introduce something new on the front end than to introduce it on the back end, because on the back end you could maybe introduce Elixir in a company that does Erlang fairly easy because those languages can coexist easily because they compile to the same virtual machine. So basically you can mix the libraries and you can do this part in Elixir, you compile it, you require it in a different part, and it works. But on the front end, everything compiles to JavaScript in the end, so you can use whatever you want. The first thing is probably you should not use use CoffeeScript, because of the same reason I mentioned before. Like, if you're writing Ruby, you don't learn Python. If you want to switch away from writing JavaScript, you don't move to a slightly less crippled version of JavaScript, because if you're it's a bit like putting lipstick on a pig. Like, it looks a little bit better, but all the problems are still there. You're making a big step, which is introducing the extra step in your application when it's like compiling your CoffeeScript files into JavaScript, and you're not getting so much out of it. You had to fight a battle to convince all the people that they're okay with you using CoffeeScript, and introduce the tooling and so on, and then you end up making the language just a little bit better, while you could be using Elm. Like, you would have to fight the same battles, but what you would get is types. And like, Elm is the ML-like language that's like functional and pure and immutable, and it's got types, and it has cool like functional rapid programming way of handling user input. Well, they have a concept of signals, which are a bit like variables that change over time, but they what's most important, and it kind of illustrates what Elm, how cool Elm is the language gives you a possibility to time travel. So, because everything is pure and immutable, you can go back in time whenever you want. Like, there was this thing that people were complaining that I'm not going to use Elm because it doesn't have a debugger. I don't use languages without debugger. And so one of the people who work on it was like, hey, I'm going to create this debugger that you're going to like. And created a time-traveling debugger, which records all the inputs that come to the application, because they are stored as signals anyway. And at some point, you can start recording, you can pause, you can go back to any state of the program, and you see what happened, like how the variables change, because everything is kept there, because everything, if it's immutable, like you get like new objects being created. And what you can do is you can change your code to fix a bug, and then you replay the same inputs and see if it's helped. What they usually do is they show a demo of a Mario game where you can like go to the right, you jump on the cloud and so on, and then you go back, you change the gravity to like half of the normal gravity, and Mario jumps twice as high, and they show where did he get now, like with those different programs and exactly the same inputs. But in real world, front-end people don't care about this shit. What they care about is when you have a drop-down menu that you control with JavaScript, and like you hover here, and then you move your mouse over here, and there's another menu that pops up, and when you move it there, everything disappears, but because there's a blank pixel. And when you fix this, you think you fixed this, and then you cannot reproduce it, and you don't know, did I really fix it, or I cannot find the bug anymore, or like because there was just only one pixel and I cannot find where it was. So what you do with Elm, you just record the whole session where you found the bug, fix the bug, and replay it. And if the bug is not there, it means you actually fixed it because the inputs are exactly the same. The mouse cursor is in exactly the same position. Even better, have your QI people, when they are testing an application, record the session, it's kept in a file, send it to developers so they can replay it to see the bug. There's no like screen recording. You can just share the compiler sessions, the debugger sessions. So, CoffeeScript, time traveling Elm, make your choice. Anyway, if you don't like types, you have the closure script. You've got the immutability, you've got speed, you've got easily you can easily do asynchronous stuff because of the correcting. You have the whole functional paradigm, and by speed, I mean it's, you know React, right? React.js. This is like a JavaScript library created by guys at Facebook that does some like weird stuff with it copies the whole DOM tree of the website and creates a virtual DOM and then compares everything everywhere. So Facebook spent a lot of time creating it and they released it. And there was one guy who thought, okay, I'm gonna write an enclosure script, and he wrote it like by himself, a naive implementation, and it was 4 times faster. And then the guys at Facebook were like, how did it happen? And the thing is that because of the immutability, like there was a lot of comparing the DOM nodes, and in React they're using just JavaScript. So if you want to compare 2 nodes, if they're the same, you have to you look at the object, you see if it has the same keys. Okay, if it has the same keys, so let's go inside every key and see if it has the same values. It has the same values. So this process is tedious, and because of like closures immutability, you compare you know that if the object changed, actually there is new object being created in memory. In closure, if you want to see if 2 objects are equal, they would have the same memory pointer. If they have different, they are different. So the whole like going deep into the nodes, the DOM tree thingy like went away because of the reassurances that the closure gives you on the code that was being created. So what I mean is you should try to if everything else fails, you can look in the front end and try to among more than 300 languages. Try to find something that you like. Like there's plenty of things to choose from, some more ridiculous than others, and you will find something that you can write yourself. Worst case scenario, you're gonna write on it on your machine and then compile it to JavaScript and put it in the repo. But it's gonna be more fun than the usual work. Another thing, like I said before, it's cool to make a switch to something that's completely different from what you were doing right now. Like Ruby Python, no, it's not cool. But for example, switching from a dynamic language to a statically typed language, this is gonna change your mind, change the way you work, you will learn something new. So, for example, if you're using Ruby, you can take a look at Crystal. This is a language that is like almost Ruby. Like the syntax is so similar that the guy who created it, he asked the Mats, the creator of the Ruby language, if he can steal all the documentation of the Ruby standard library, change that it says on top Crystal, and put it as his own documentation. All the examples, all the syntax, what the methods do, and so on. And then the Mats responded, yeah, sure, I stole it from Perl anyway. So the thing is that there is a language that has the same syntax up to the point that there's a lot of Ruby. If you don't use metaprogramming, your normal Ruby programs you can just pass through the Crystal compiler, and the only thing that's going to be visible as a difference is that they are 10 times faster, because that's approximately how much faster Crystal is. And your code is going to be static, like on compile time, it's going to be type checked. And because the types are inferred, you don't really have to specify them. Just try to infer it. That's why the Ruby code put through the Crystal compiler will still work. But if you want, you can do your own pipe annotations. What you can do if you use Ruby, you just take one of those small services that subscribe to this like publish or subscribe queue and run it through the compiler and see what happens. And if it works well, if it compiles, just put it on staging server, let it run there, see if it works, and if it works, it's just like for free 10 times faster. The last thing I want to talk about is the so-called agile mindset. It has nothing to do with this like Scrum agile management thingy. It's like there are 2 kinds of mindset, like a fixed mindset and a growth mindset. Fixed mindset is concentrating on who you are, and the growth mindset is concentrating on what I do. So, example of a fixed mindset would be, I am a Ruby programmer. Example of the growth mindset would be, I write Ruby in my daily job. The difference is that you don't put the Ruby as part of your identity. It's not something who you are, it's something what you do. There were like various experiments about it, and the simplest way of seeing this was like they took two groups of children and they made them do a test which was fairly easy. And well, actually it works with adults as well. So they took two groups of people, they made them do a test, it was easy, everybody scored well, and to group A they told, oh, you did really well, you must be really smart. And to group B they said, oh, you did really well, you must have worked hard. And then they everybody's happy, and they came back to them and saying, okay, we have a second test which is more difficult. Do you want to see how well you're gonna do at this test? And the people who are supposedly smart, they didn't want to take the second test. They were like, yeah, sure, yeah, but I'm like cooking my soup at home and I have to go check on it. Like, I don't really want to do it, because they didn't force them, and they gave them opportunities. And most of the people who were praised on putting a lot of effort into it, they wanted to do the difficult one because they felt like, okay, I did well because I put effort. So I will do well in the second one if I put effort in it. But the first one, the smart group thought, okay, what might happen that I do this test and they tell me it's the more difficult, what happens if I'm not smart anymore? Like, what happens if I fail the test? And they didn't want to do it, so they didn't want to push themselves. This is the mindset, like, I'm a Ruby programmer, I'm gonna program Ruby, I'm not touching the front-end stuff, I'm a back-end programmer, I'm a front-end programmer. So all those are all the fixed mindset. What we should be aiming for is not associate what we want to do, what we want to learn with what we're doing right now. Just like a phase, we're gonna move through it and learn something new, hopefully. So the point is, you shouldn't be this guy who's like, who doesn't know how to count and lives in a small village at the end of the world. Should be this guy who got left by his wife because he became an atheist and like his children don't love him. No, actually, like his story is super complicated. But we should be more like this guy because he learned new stuff and he changed his life and he looks pretty happy in this picture. Anyway, that's all. Anything you would like to comment on? Ask any questions?
Yes. Have you done this in your work?
Yes, a little bit.
This is recording, eh? This is being recorded.
No. The thing is, yeah, the JavaScript stuff, yeah, the JavaScript is fairly easy to pull off, to switch from JavaScript to something else. In one of the companies, I did the sneaky switch of when we were doing some migration, we did an enclosure, and I was actually open to do it in any language, and the guy I worked with, he liked Clojure, and we did enclosure, and it turned out well. And we basically got the green light for any new project that comes up. We can do it in Clojure. But in the end, I went the easy way, and I started my own company where I can do whatever I want, which is kind of like cheating. But
another question. Wouldn't it be easier to just look for a job where they want this new language you want to learn instead of...
That's a very good point. And that's what I wanted to do for many years. And the problem is that I had like 7 years of Rails experience. So if I wanted to do a job in Ruby, it's easy to get one, and the salary is nice. And if I want a job in Haskell, then I don't know shit, I have no experience, and I get the junior level salary, which might be a stopper for a lot of people. Like, for me, I might be able to pull it off, but if somebody has family and kids, the money thing for the switch, it's not gonna go well. There are some combinations that work well for it. For example, there are a lot of people who are looking for Ruby and Clojure, like people who are experienced with Ruby and want to learn Clojure, or Ruby and Elixir works really well. There is quite easy, I think, to switch from Java to Clojure because of the whole JVM, like a lot of stuff that you already know, you can like offer them as your experience. There's Scala, which is like a gateway drug as well, that if you can write Scala like if you wrote Java, so it's easy to get in, but then you can write it more like you would write Haskell, for example, and you can evolve into the direction you want. But these are like a lot of super one language connected things.
And one more question. Isn't it kind of immoral?
I'm glad you asked this.
Okay.
I forgot about it. But the thing is that we get hired. Now we're talking about not a client project when you're just a consultancy that gets hired by a client to do one thing, because experimenting there, it's not cool because he's paying you by the hours you spend on it. But if you enter into an employment contract with someone, and this is an undefined like length of the contract, contrato indefinido, then I think it is in your part of your responsibilities to make yourself a better programmer. Because he's expecting you to gain more experience and be better. He's giving you raises every year, hopefully. And I think it's this kind of growth, experimenting with new stuff, learning new stuff, will make you a better programmer, and you will deliver more value to it. Even like the whole sneaky thing under the radar, I'm gonna switch languages and nobody's gonna notice. That's for situations where a lot of people don't understand what's good for them. Like this whole concept of social security is based on people not doing stuff that's good for them, like saving retirement money. And there's a lot of, I think a lot of managers would have a problem with, like, it would take a lot of their time, and it would be like, basically, it's worthless to spend on a conversation whether it would make me a better programmer if I learned a new language like Haskell. Like, I cannot imagine even having this conversation with him, so I can imagine convincing him. So the only thing I can do is like a dirty trick to make him allow me to do it. But in the end, I think it is one of our responsibilities as employees to get better, to learn more stuff, because in the end, he's getting the benefits of it.
But still, you will have to keep some level of quality in the
Sure,
project.
sure.
I mean, you
Sure,
can't just play in.
No,
work
it's
with
like
technology.
you cannot do it like 8 hours a day, 5 days a week, and hoping nobody notices. Like a lot of companies have those like innovation weeks or Slack time where on Fridays you do whatever you want. There is also if your company doesn't have anything like this and you have some kind of small service that you would like to write in another, you can just invest some of your own time that nobody pays you for and rewrite it. And if it's better, in hope that later you will be allowed to work on it for money. But this is like somebody's personal decision if they want to invest some of their time, and time is money, and like you can spend the time in a better way than writing code for your employer that nobody pays you for. But in general, of course, you have to. It's not like, and you can exchange in any languages. Like for example, it would be difficult to convince a Ruby shop to do Haskell. This is gonna be difficult. But convince a Ruby shop to do Crystal, that's doable. Convince them to do Clojure, because there's a lot of movement from Ruby to Clojure, this would be doable. And what you can do is, for example, like first convince them to use JRuby, which runs on JVM, and then, because we have already the JVM installed on the server, maybe I can do this part in Clojure, right? And the JRuby is just like the Trojan horse to the JVM on the server. So I think it should be done like with small steps, like I said before, like the small changes, 1 week tops, because you can go to your boss and tell him like, give me 1 week, I'm gonna show you something really cool, or otherwise I'm gonna lose a week, but a week is not that much. Any more questions from you?
No, I don't. Thanks. Anyone else has a question?
Couple of things. One is kind of the role of pet projects. For example, I wanted to do project, no one else did, and I started pet projects, and some of them actually became useful. And that's, I don't know if you had any.
Yeah, I didn't mention. Well, I would like skip through it in the beginning. The thing is that my problem with pet project is personally I don't have time for that. Like I have a problem of taking too many like responsibilities. Like I promise people stuff and then I have to deliver, and what I really want to do gets pushed in the back. And I can, for example, I can figure out how to spend half a day every week on a pet project. But if you spend half a day every week, then you're gonna be like forgetting half of what you learned the previous week, and it's not really, it doesn't work. If it works well for you, I mean, if you can find the time, or for example, if you taking 2 weeks of holidays and just writing a pet project and staying at home, then it's cool. Like it's a good way of doing this. It didn't work for me personally because of the like other priorities, but so that's why all of this was about like pushing it at work. But if you're able to do a pet project, it's really cool. It can show you can show it on GitHub and find a job in the new language, because you can show like measurable experience in it. You can find stuff that people are using. You can, okay, here's my code in Clojure, hire me as a Clojure programmer.
I have a question. Do you know any tool you could use, for example, to write a backend or an API in any of that languages, just to learn, but it makes you easy. For example, if I work as an Android developer and I have a side project and I want to make an API, I actually was thinking about not Ruby, it was Elixir, because some of my friends talk well about the language. So I wanted to write something in Elixir. But is there any tool you could, because I don't know a way to make an easy API with a new language, with a new programming language. So
this is actually a cool problem to get. Like if you want to do an API for a mobile project, there's plenty of companies this is a simple project relatively. Like it's not super complicated, and there are a lot of people who do blog posts like, oh, here's how we built our JSON API with Go. And they have a blog post about it from beginning to end. And what I would recommend starting with is going through 4 or 5 of those blog posts and going like implementing yourself, like writing yourself the code.
From scratch?
From scratch, like here you have the browser, here you have your editor, you type it. You just like, you don't copy paste it.
Okay.
And you can find one for Elixir, for Haskell, for Go, for Ruby. Plenty of those, and you like do 4 or 5, and then see which one you liked, which one had the feel, which one you liked the tooling, which one made sense for you, and then try to you have to go from there to get a book or something. And so, but first, I would, especially if you're not constrained to any language, just see what's out there and see what you like. You had more questions?
I just have one other question. Have you had any experience with using ProjeScript?
Debugging?
Yes.
Small. But from what I understand, the source maps now works pretty well, and you're able to see the source where the Clojure script through an error, not where the JavaScript generated through an error.
I used it about a year ago, and I thought completely
the Clojure script project moves really fast. Manuel probably knows more about it.
Seen a lot. Now with the Figwheel and all that, it's getting.
So the ProjeScript debugger is now quite sophisticated, isn't it?
The things that they were talking about doing it, that you didn't need the Java virtual machine to use it. It's done in JavaScript. They're going in that direction. So they are having some functionality to make it really interactive. The way they work with when they are coding, with the thick wheel and all that. You can really be doing changes with your code and seeing really instantly because they are pushing those changes in the front end.
The new cool thing is
It's changing very fast.
yeah, the new cool thing is that now there's the React Native, which is like React.js for native applications that generates like iOS or Android apps. Because it's written in JavaScript, so you can write closure script. So people set up the fig wheel. The manual mentioned that you write closure script, and this automatically picks up the changes and reruns the apps in the Android and the iOS simulators. So you can actually like when you're just in your editor and you see how stuff is changing, and the whole workflow is supposedly amazing. I still need to look at it, but people are really happy with the way that we work with ClojureScript right now. But this is the benefit of those like new languages, that they move really fast forward, and it's very easy for them to like take the ideas from somewhere else and to copy stuff. Anything else? Cool. So thanks, and I hope you enjoyed it.